If we want to understand what actual aliens might look like, we have to start by looking at our own oceans and forests. Biology on Earth thrives in extreme places, producing creatures that look entirely alien, like the blue dragon sea slug. Or consider the eye. Its oversized ears and exceptionally long middle finger are highly specialized adaptations for tapping on wood and pulling out hidden grubs in the dark. These strange features exist because Earth's specific physics and environments required them. If you take the exact same principles of adaptation and apply them to worlds with different gravity, atmospheric pressure, or sunlight, the resulting organisms will take on vastly different shapes. So, let's step into the evolutionary sandbox. By taking real astrophysical data and manipulating key environmental variables, we can construct 3 viable alien worlds. We can assume the biology found on these worlds follows the same rigid logic as ours, adapting with mechanical precision to the constraints of its local environment. Welcome to Glacis Prime. This is an ice planet orbiting the dim red dwarf Crimson Hearth. Because it is tidally locked, meaning its rotation matches its orbit, one side permanently faces the star in eternal day, while the other is locked in an eternal freezing night. On Earth, we have an incredibly bright white sun. Our plants evolved to be green because that color is the most efficient at absorbing the specific high-energy wavelengths our sun puts out. But the liquid ocean of Glacis Prime, the dark oasis, receives only the weakest, dimmest rays from its red dwarf star. To survive here, alien plants evolved to be pitch black, absorbing every single scrap of the weak infrared energy available to them. This creates a secondary constraint. In a murky ocean choked with black vegetation and bathed in almost no visible light, evolving eyes is a complete waste of biological energy. This diagram shows how a blind hunter, like the claw star, constructs a detailed picture of its surroundings. Instead of sight, creatures like the silt sifter and venom pods navigate entirely by projecting localized sound waves and reading the physical textures of the water pressure as it bounces back. Because Glacis Prime never experiences seasons or a day-night cycle, its climate never shifts. This eternal physical stability results in a terrifyingly efficient, unchanging biological food web that can operate exactly like this for billions of years. Our second destination is Goliath. It is a massive, churning gas giant continuously showered by intense radiation from the blisteringly hot blue star Azure Wrath. Down here, there is no solid ground to stand on. Biology on this world faces a single, harsh imperative: do whatever it takes to stay afloat. If an organism sinks too far down into the gas giant's crushing depths, it dies. Survival means mastering atmospheric charge differences, or thermal lift. Trillions of microscopic cloud plankton achieve this lift by casting out wispy electrostatic threads. Similar to some small spiders on Earth, they use these threads to pull against the natural electrical charge of the atmosphere and ride the gentle updrafts. To harvest that microscopic plankton, life evolved the Zeppelin leviathans. Like the blue whales of Earth, they grew massive to filter huge amounts of food. But a leviathan can easily reach the size of a skyscraper, maximizing the internal volume of its gas envelopes to produce the required lift. This schematic outlines the energy economy of the Zeppelin leviathan. It lowers a massive, sticky net to sweep up plankton, then pulls the catch into internal glands, processing it into a dense, high-energy nectar to heat its gas. That nectar is highly coveted. Rocket predators hunt the leviathans by superheating their own internal gases and expelling them in violent bursts. They fly like high-speed biological missiles, piercing the skin of the leviathans to drain their fuel reserves. Yet all life on Goliath is doomed. Blue stars like Azure Wrath burn through their fuel at an extreme rate. Within a few million years, the star will swell and completely consume this entire aerial ecosystem. Our final stop is Ethelgard. It is a freezing, toxic moon orbiting a brown dwarf called Magnetar Minor. Gravity here is only 5% of Earth's, but the moon sits inside a monstrously powerful magnetic field. That massive magnetic field catches raw star plasma and pulls it down into the atmosphere, creating overwhelming planet-wide auroras that constantly illuminate the sky. Ethelgard has an extremely fast orbit, giving it a sun cycle of only 3 hours. Similar to Arctic flowers on Earth that sprout quickly in short summers, the plants here violently unspool from the ice the moment the sun crests the horizon to maximize their narrow window of light. This vector diagram illustrates exactly how they grow so fast. The plant tissues are completely saturated with conductive metals. They lock on to the atmospheric magnetic lines of force and, aided by the low gravity, physically levitate themselves high into the air. Animals tap into this force as well. Volt gliders deploy biological magnetic kites to surf across the surface at immense speeds. To catch them, heavy, metallic crystal trappers bury themselves in the dirt, hunting entirely by detecting the electrical disturbances the gliders create as they pass overhead. On Ethelgard, biology has effectively merged with planetary physics, turning magnetism and cryovolcanism into the fundamental drivers of life. Returning home, Earth suddenly feels incredibly calm. This is the baseline we evolved specifically to inhabit, where our gravity, air, and sunlight perfectly match our biology. Predicting the forms of alien life isn't fantasy. It is the strict application of known astrophysical rules to entirely unknown environments.